हेलो फ्रेंड्स, तो राना अकेडमी में आपका स्वागत है। हमने स्टार्ट किया 12th क्लास की एनसीईआरटी की वन शॉट सीरीज, जिसमें हमने 9th यूनिट तक कवर अप किया है। तो हम स्टार्ट करते हैं 10th यूनिट, जो कि हमारा हेलो अल्केन एंड हेलो अरेन्स। The replacement of hydrogen atom in an aliphatic and aromatic hydrocarbon by halogen atom results in the formation of alkyl halide, haloalkane, and aryl halide, haloarene, respectively. Haloalkanes contain halogen atom attached to the sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contain halogen atoms attached to sp2 hybridized carbon atoms of an aryl group. Many halogen containing organic compounds occur in nature, and some of these are clinically useful. These classes of compounds find wide applications in industry as well as in day-to-day life. They are used as solvents for relatively non-polar compounds and as starting materials for the synthesis of wide range of organic compounds. Chlorine containing antibiotic chloramphenicol produced by microorganisms is very effective for the treatment of typhoid fever. Now our body produces iodine causes a disease called goiter. The synthetic halogen compounds. Otherwise, chlorogen is used for the treatment of malaria. Halothine is used for as an anesthetic during hand surgery. Now, certain fully fluorinated compounds are being considered as potential blood substituted in surgery. In this unit, we will study the important methods of preparation, physical and chemical properties of useful uses of organohalogen compounds. Classification on the basis of number of halogen atoms. Haloalkanes and haloarenes may be classified as follows. These may be classified as mono, di, and polyhalogen, tetra, etc. Compounds depending on whether they contain one, two, or more halogen atoms in their structures. For example, monohaloalkane, dihaloalkane, trihaloalkane, monohaloarenes, dihaloarenes, trihaloarenes. Monohalo compounds may further be classified according to the hybridization of the carbon atom to which the halogen is bonded, as discussed below. Compounds containing sp3 carbon halogen bond. These classes includes alkyl halides and haloalkanes. Now, the alkyl halides, the halogen atom is bonded to an alkyl group R. They form homologous series represented by Cn S2n plus 2x, and they are further classified as primary, secondary, and tertiary according to the nature of carbon to which halogen is attached. If halogen is attached to nature of carbon to which halogen is attached. If halogen is attached to a primary carbon atom in an alkyl halide, the alkyl halide is called primary alkyl halide or primary alkyl halide. Similarly, if the halogen is attached to secondary or tertiary carbon atom, the alkyl halide is called secondary alkyl halide or and tertiary alkyl halide respectively. Allylic halides. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom adjacent to carbon-carbon double bond, that is to an allylic carbon. Benzylic halides. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. Compounds containing sp3 carbon X bonds. And this class includes vinylic halides, aryl halides. Nomenclature. Having learned the classification of halogenated compounds, let us now learn how these are named. The common names of alkyl halides are derived by the naming of alkyl group followed by the name of halide in the IUPAC system of nomenclature. Alkyl halides are named as halo substituted hydrocarbons. Now, for monohalogen substituted derivatives of benzene. Common and IUPAC names are the same. For the dihalogen derivatives, the prefixes O, M, P are used in common system, but in IUPAC system, you have learned in class 11, unit 12, the numerals 1.2, 1.3, 1.4 are used. N-propyl bromide, IUPAC name 1 bromopropane. Isopropyl chloride, 2 chloropropane, isobutyl chloride, 1 chloro 2 methyl propane, bromobenzene, N-dibromobenzene, 1,3-dibromobenzene, sim-dibromobenzene, 1,3,5-tribromobenzene. IUPAC name. The dihaloalkanes having the same type of halogen atom are named as alkyline and alkyline dihalides. The dihalo compounds having both the halogen atoms are further classified as geminal halides or gem dihalides when both the halogen atoms are present on the same carbon atom of the chain, and vicinal halides of vis dihalides when halogen atoms are present on adjacent carbon atoms. In common name system, gem dihalides are named as alkylidine halides and vis dihalides are named as alkyline dihalides. In IUPAC system, they are named as dihaloalkenes. Table 10.1 Common and IUPAC name of some halides. Nature of carbon halogen bonds. Halogen atoms are more electronegative than carbon. Therefore, carbon halogen bond of alkyl halide is polarized. The carbon atom bears a partial positive charge, whereas the halogen atom bears a partial negative charge. As we go down the group in the periodic table, the size of the halogen atom increases. Fluorine atom is the smallest, and iodine atom is the largest. Consequently, the carbon halogen bond length also increases from carbon fluorine and carbon iodine. Some typical bonds lengths. Bond enthalpy and dipole moments are given in table 10.2. Alkyl halides are best prepared from alcohols which are easily accessible. Table 10.2 Carbon halogen bond lengths and bond enthalpies and dipole moments. Methods of preparation of haloalkanes. The hydroxyl group of an alcohol is replaced by a halogen on reaction with concentrated halogen acids, phosphorus halides, and thionyl chloride. Thionyl chloride is preferred because in this reaction alkyl halide is formed along with the gases SO2 and HCl. The two gases products are escapable. Hence, the reaction gives pure alkyl halides. The reactions of primary and secondary alcohols with HCl require the presence of the as catalyst. ZnCl2 with tertiary alcohols. The reaction is conducted by simply shaking the alcohol with concentrated HCl at room temperature. Constant boiling with their HBr is used for preparing alkyl bromide. Good yields of Ri may be obtained by heating alcohols with sodium and potassium iodide is in 95% orthophosphoric acid. The order of reactivity of alcohols with a given halo acid is the tertiary is greater than secondary is greater than primary. Phosphorus tribromide and triiodide are usually generated in situ, produced in the reaction mixture by the reaction of red phosphorus with bromine and iodine on respectively. The preparation of alkyl chloride is carried out by either by passing a dry hydrogen chloride gas through a solution of alcohol or by heating a mixture of alcohol and concentrated aqueous halogen acid. The above methods are not applicable for the preparation of aryl halides because the carbon oxygen bond in phenols has the partial double bond character and is difficult to break, being stronger than a single bond from hydrocarbons. From alkanes by free radical halogenation. Free radical chlorination and bromination of alkanes gives the complex mixture of isomeric mono and polyhaloalkanes, which is difficult to separate as pure compounds. Consequently, the yield of any single compound is low. As from alkenes, addition of hydrogen halides, the alkene is converted to corresponding alkyl halide by reaction with the hydrogen chloride hydrogen bromide and hydrogen iodide. Propane yields two products, however, only one predominates. As per Markovnikov rule, Unit 13, Class 11, addition of halogens in the laboratory, addition of bromine and CCl4 hand to an alkene, resulting in a discharge of reddish a brown color of bromine constitutes an important method of for the detection of double bond in a molecule. The addition results in the synthesis of Weiss on dibromide, which are colorless. Halogen exchange. Alkyl iodide are often prepared by the reaction of alkyl chloride bromides with the NaI in dry acetone. This reaction is known as Finkelstein reaction. NaCl and NaBr, which thus formed, is precipitated in dry acetone. It facilitates the forward reaction according to according to Le Chatelain principles. The synthesis of alkyl fluorides is best accomplished by heating an alkyl chloride bromide in the presence of metallic fluoride, such as the reaction is termed as Schwarz reaction. Preparation of haloarenes from hydrocarbons by electrophilic substitution. Aryl chlorides and bromides can be easily prepared by electrophilic substitution of arenes with the chlorine and bromine respectively in the presence of Lewis acid catalysts like iron and iron 3 chloride. The ortho and para isomers can be easily separated due to the difference in their melting points. Reactions with iodine are reversible in nature and require the presence of an oxidizing agent HNO3, HNO4, now 2 oxide on the HI formed during iodination. Now, fluoro compounds are not prepared by this method due to high reactivity of fluorine from amines by Sandmeyer's reaction. When a primary aromatic amine dissolved or suspended in cold aqueous mineral acid now is termed with the sodium nitrite, diazonium salt is formed. Mixing the solution of freshly prepared diazonium salt with cuprous chloride and cuprous bromide results in the replacement of the diazonium group by Cl and Br. Replacement of the diazonium group by iodine does not require the presence of cuprous halides and is done simply by shaking the diazonium salt with potassium iodide. Physical properties. Alkyl halides are colorless when pure, however, bromides and iodides develop color when exposed to light. Many volatile halogen compounds have sweet smell. Melting and boiling points: methyl chloride, methyl bromide, ethyl chloride, and some chlorofluoromethanes are gases at room temperature. Higher the members are liquids or solids. As well as we have already learned, molecules of organic halogen compounds are generally polar due to greater polarity as well as higher molecular mass as compared to the parent hydrocarbon. Now, the intermolecular forces of attraction, dipole and van der Waals, are stronger in the halogen of derivatives. That is why the boiling point of chlorides, bromides, and iodides are considerably higher than those of the hydrocarbons of comparable molecular mass. The attraction gets stronger as the molecules get bigger in size and have more electrons. The pattern of variation of boiling points of different halides is depicted in figure 10.1 for the same alkyl group. The boiling points of alkyl halides decrease in the order RI, RB, RCl, RF. This is because with the increase in size and mass of halogen atom, the magnitude of van der Waals forces increases. At figure 10.1, comparison of boiling points of some alkyl halides. The boiling points of isomeric haloalkenes decrease with the increase in branching. Now, 2-bromo, 2-methyl propane has the lowest boiling point among the three isomers Boiling points of isomeric dihalobenzene are very near the same. However, the para-isomers are high melting as compared to their ortho and meta-isomers. It is due to summary of para-isomers and fits in crystal lattice better as compared to ortho and meta-isomers. Density: bromoiod and polychloride derivatives of hydrocarbons are heavier than water. The density increases with increase in number of carbon atoms, halogen atoms, and the atomic mass of the halogen atoms. Table at 10.3 density of some haloalkanes. Solubility: the haloalkanes are very slightly soluble in water. In order to dissolve haloalkanes in water, energy is required to overcome the attractions between the haloalkane molecules and break the hydrogen bonds between the water molecules. Less energy is released when new attractions are set up between the haloalkane and the water molecules, as these are not as strong as the original hydrogen bonds in water. As a result, now the solubility of haloalkanes in water is low. However, haloalkanes tend to dissolve in organic solvents because the new intermolecular attractions between haloalkanes and the solvent molecules have much the same strength as the one being broken in the separate haloalkane and solvent molecules. Chemical reactions: reactions of haloalkanes. The reactions of haloalkanes may be divided into the following categories: nucleophilic substitution, elimination reaction, reaction with metals. Nucleophilic substitution reaction: you have learned in class 11 that nucleophiles are electron rich species, therefore they attack at the part of the substrate molecule which is the electron deficient. The reaction in which the nucleophile replaces already existing nucleophile in the molecule is called nucleophilic substitution reaction. Haloalkanes are substrate in this reaction. In this type of reaction, the nucleophile reacts with haloalkane, the substrate, having the partial positive charge on the carbon atom bonded to halogen. A substitution reaction takes place and halogen atom called having living group departs or the halide ion. Since the substitution reaction is initiated by the nucleophile, it is called a nucleophilic substitution reaction. It is one of the most useful classes of organic reactions of alkyl halides in which halogen is bonded to sp3 hybridized carbon. The products formed by the reaction of halogens with some common nucleophiles are given in table 10.4. Nucleophilic substitution of alkyl halides group like cyanides and nitrates possess two nucleophilic centers and are called ambivalent nucleophiles. Actually, cyanide group is a hybrid of two contributing structures and therefore can act as a nucleophile in two different ways. C double bond N, C double bond N. Now that is linking through a carbon atom resulting in alkyl cyanides and through a nitrogen atom leading to isocyanides. Similarly, a nitrate ion also represents an abundant nucleophile with two different points of linkage, ON double bond O. The linkage through oxygen results in alkyl nitrides, while through nitrogen atom it leads to nitroalkanes. Mechanism: this reaction has been found to proceed by two different mechanisms which are described below. Substitution: nucleophilic molecular bimolecular. The reaction between CH3Cl and hydroxide ion to yield methanol and chloride ion follows the second order kinetics. Now that is the rate of depends upon the concentration of both the constant reactants. The above reaction can be represented diagrammatically as shown in figure 10.2. 10.2 figure: red ball represents the incoming hydroxide and incoming hydroxide ion, and green ball represents the outgoing halide ion. It depicts the bimolecular nucleophilic substitution and SN2 reaction and the incoming nucleophile interacts with alkyl halide, causing the carbon halide bond to break down. The new bond is formed between the carbon and attacking nucleophile. Here it is carbon oxygen bond formed between carbon and OH. These two processes take place simultaneously in a single step, and no intermediate is formed as the reaction progresses, and the bond between the incoming nucleophile and the carbon atom starts forming. The bond between carbon atom and living group weakens. This happens as the three carbon hydrogen bonds of the substrate start moving away from the attacking nucleophile in transition state. All the three CH bonds are in the same plane, and attacking and living nucleophiles are partially attached to the carbon. As the attacking nucleophile approaches closer to the carbon, CH carbon nucleophile attaches to carbon, and living group leaves the carbon atom under attack. Inverts in much the same way as an process is called inversion of configuration. In the transition state, the carbon atom is simultaneously bonded to incoming nucleophile, and the outgoing living groups. Such structures are unstable and cannot be isolated. Thus, in the transition state, carbon is simultaneously bonded to five atoms. Since this reaction requires the approach of the nucleophile to the carbon-bearing the living group, the presence of bulky substituents on the or near the carbon atom have the diagrammatic and the inhibiting effect of simple alkyl halides. Methyl halides react most rapidly in SN2 reaction because there are only three small hydrogen atoms. Tertiary halides are the least reactive because bulky groups hinder the approaching nucleophiles. Thus, the order of reactivity followed is primary halide is greater than secondary halide is greater than tertiary halide. Substitution nucleophilics, the monomolecular SN1 reactions are generally carried out in polar protic solvents like water, alcohol, acetic acid, etc. The reaction between tertiary butyl bromide and hydroxide ionides tertiary butyl alcohol and follows the first order kinetics, and that is the rate of reaction depends upon the concentration of only one reactant, which is tertiary butyl bromide. It occurs in two steps. Step 1, the polarized carbon bromide bond undergoes slow cleavage to produce carbocation and bromide ion. The carbocation thus formed is then attacked by nucleophile in step 2 to complete the substitution reaction. Step 1, the lowest and reversible. It involves the carbon bromide bond breaking off, for which the energy is obtained through solvation of halide ion with the proton and of protic acid solvent. Since the rate of reaction depends upon the solvent, slowest step, the rate of reaction depends only on the concentration of alkyl halide and not on the concentration of hydroxide ion. Further, greater the stability of carbocation, greater will be on its ease of formation from alkyl halide, and faster, very fast, because of the high stability of tertiary carbocation. We can come on. We can sum up the order of the reactivity of alkyl halides towards SN1 and SN2 reactions as follows. For the same reactions, allylic and benzylic halides show high reactivity towards the SN1 reaction. The carbocation are formed get stabilized through through resonance. Again, class 11 12 unit has shown below. For a given alkyl group, the reactivity of the halide Rx follows the same order in the both mechanism. Ri is greater than Rb, R is greater than Rcl is greater than Rf. Figure 10.4, some common examples of chiral and achiral objects. The figure 10.7, a chiral molecule and its mirror image. Figure 10.6, A is mirror image and D is to E is rotated by 180 degree to get F, and F is non-superimposable on its mirror image D. Location of alpha and beta carbon in a molecule. Carbon on which halogen atom is directly attached is called alpha carbon atom, and the carbon atom adjacent to this carbon is called beta carbon. Elimination versus substitution. A chemical reaction is the result of competition. It is the race that is won by the fastest runner. A collection of molecules tend to do by and large from what is the easiest for them. An alkyl halide with beta hydrogen atom when reacted with the a base or a nucleophile has two competing routes. Substitution as the SN1, SN2, and elimination, which route will be taken. Direction reaction conditions. Thus, the bulkier nucleophile will prefer to act as a base and abstract a proton rather than approach a tetravalent carbon atom steric regions, and vice versa. Similarly, a primary alkyl halide will prefer a SN2 reaction, a secondary halide SN2 or elimination depending upon the strength of the base nucleophile, and the tertiary halide SN1 or elimination depending upon the stability of higher carbocation or the more substituted alkane. Reaction with metals. Reaction of haloarenes. Nucleophilic substitution reaction. Aryl halides are extremely less reactive towards nucleophilic substitution reactions due to the haloarenes and due to following reasons. Reaction resonance effect. The haloarenes, the electron pairs are on a halogen atom are in conjugation with pi electrons of the ring, and the following resonating structures are possible. CCl bond acquires a partial double bond character due to resonance. As a result, the bond cleavage in a haloarene is difficult than a haloalkane, and therefore they are less reactive towards nucleophilic substitution reaction. Difference in hybridization of carbon atom in CX bond. In haloalkane, the carbon atom attached to halogen is sp3 hybridized, while in case of haloarene, the carbon atom attached in halogen is sp2 hybridized. The sp2 hybridized carbon with the greater s character is more electronegative and can hold the electron pair of CX bond more tightly than sp3 hybridized carbon in haloalkane with the less s character. The CCl bond length in haloalkane is 177 pm, while in haloarene is 169 pm. Since it is difficult to break a shorter bond than the longer bond, therefore haloarenes are less reactive than haloalkanes towards nucleophilic substitution reaction. Instability of phenyl cation. In case of haloarenes, the phenyl cation formed as a result of self-ionization will not be stabilized by resonance, and therefore SN1 mechanism is ruled out. Because of the possible repulsion, it is less likely for the electron-rich nucleophile to attach to electron-rich arenes. Replacement by hydroxyl group. Chlorobenzene can be converted into phenyl by heating in aqueous sodium hydroxide solution at a temperature of 623 Kelvin and the pressure of 300 atmospheres. Electrophilic substitution reaction. Friedel-Crafts reaction. Reaction with metals. Polyhalogen compounds. Dichloromethane, methylene chloride, dichloromethane, chloroform, triiodomethane, iodoform, tetrachloromethane, carbon tetrachloride, France, PP dichloro, dichlorodi, phenyl trichloromethane, DDT. Summary. Alkyl haloalkenes and haloarenes की summary. Alkyl aryl halides may be classified as mono, di, and polyhalogen, tri, tetra, etc. compounds depending on whether they contain on two or more halogen atoms in their structures. Since halogen atoms are more electronegative than carbon, the carbon halogen bond of alkyl halide is polarized. The carbon atom bears a partial positive charge and the halogen atom bears a partial negative charge. Alkyl halides are prepared by the free radical halogenation of haloalkenes. Alkenes is the addition of halogen acids to alkenes, replacement of OH group of alcohols with halogens using phosphorus halides, thionyl chloride of or halogen acids. Aryl halides are prepared by for electrophilic substitution of arenes. Fluorides and iodides are best prepared by halogens. The exchange method. The boiling points of organohalogen compounds are comparatively higher than the corresponding hydrocarbons because of strong dipole-dipole and van der Waals forces of attraction. These are slightly soluble in water but completely soluble in organic solids. The polarity of carbon-halogen bond of alkyl halides is responsible for their nucleophilic substitution, elimination, and their reaction with metal atoms or to form organometallic compounds. Nucleophilic substitution reactions are categorized into SN1 and SN2 on the basis of their kinetic properties. Chirality has a profound role in understanding the reaction mechanism of SN1 and SN2 reactions. SN2 reactions of chiral alkyl halides are characterized by the inversion of configuration, while SN1 reaction are characterized by racemization. A number of polyhalogen compounds, example dichloromethane, chloroform, iodoform, carbon tetrachloride, freon, and DDT, have many industrial applications. However, some of these compounds cannot be easily decomposed and even cause depletion of ozone layer and are proving environmental hazard. सो हेलो एल्केन्स एंड हेलो एलेंस 12th क्लास का NCERT का चैप्टर है हमारा. सो वन शॉट सीरीज में हमने इसको कवर किया है. सो पहले से देखते हैं. यूनिट हमारा 10 है. हेलोअल्केन्स एंड हेलोअरेंस 12th का हमारा चैप्टर NCERT का. क्लासिफिकेशन देखा हमने ऑन द बेसिस ऑफ नंबर ऑफ हेलोजन एटम्स, कंपाउंड्स कंटेनिंग sp3CX, कंपाउंड्स कंटेनिंग sp2CX बॉन्ड, nomenclature, IPAC name, nature of carbon X bond, method of preparation of haloalkenes from alcohols, from hydrocarbons, from halogen exchange, preparation of haloarenes. देन उसके बाद फिजिकल प्रॉपर्टीज, देन उसके बाद केमिकल रिएक्शंस ऑफ haloalkenes, टेबल 10.4, देन उसके बाद कॉन्फ़िगरेशन, देन उसके बाद चैरिलिटी, कायरलिटी. उसके बाद हमने देखा एलिमिनेशन वर्सेस सब्स्टिट्यूशन, रिएक्शन विद मेटल्स, रिएक्शंस ऑफ haloarenes, न्यूक्लियोफिलिक सब्स्टिट्यूशन, electrophilic substitution reaction, Friedel-Crafts reaction, reaction with metals, polyhalogen, dichloromethane, trichloro, triiodo, tetrachloro, freons, papicyl dichloro, and haloarenes and haloalkenes की समरी. सो यहाँ पर ख़त्म होता है हेलोअल्केन्स एंड हेलोअरेंस, जो कि 12th का हमारा NCERT का चैप्टर है, 10th का यूनिट का. सो प्लीज़ इस वीडियो को ज़्यादा से ज़्यादा लाइक कीजिएगा और प्लीज़ लाइक शेयर एंड सब्सक्राइब. थैंक यू सो मच फॉर वॉचिंग.